Welcome to today's webinar, Collecting Remote Asset Locations Using GNSS, GIS Apps, and Laser Offset Mapping, brought to you by GPS World Magazine and our sponsor of the event, LaserTech. Today you will learn mapping workflows and the offset position accuracies you can achieve with equipment you already own, and get to know the Laser GIS mapping solution. I'm Grace Ryback from North Coast Media, Content Marketing Project Manager for GPS World, and I will be the moderator for today's event. Before we get started, I want to let you know that today's webinar will be recorded. You are currently in a listen-only mode. A recording of this webinar will be posted to gpsworld.com/webinars and will also be emailed to you tomorrow. Now at this time, I'd like to acquaint you with the ways in which you can participate during today's presentation. Please notice the Q&A panel on the right side of your console. If you have a question, type it in the panel's text box, then click Submit to place your question in queue. We encourage you to ask and enter any questions you may have for our speakers about their presentations throughout the event. We will address these questions at the end of the presentation during our Q&A session. If you experience any technical difficulties during today's event, you may use the same Q&A panel to the right of the screen to submit your issue, and Assistant Producer Mackenzie Schoner or I will personally assist you. If you have a question for LaserTech or for our speakers, you can also submit your questions to them directly within the console by using the Contact Laser Technology widget that is to the left of the screen. You may learn more about our speakers by viewing their photos, bios, and email addresses in the panel located on the upper left-hand corner of your console. And if you're logged into your social media accounts, you can share the webinar's title, description, and URL with your friends or colleagues using the Share This widget. Now I'd like to introduce today's speakers. Today we will be hearing from Derrick Reish, Senior Project Manager for LaserTech. Derrick provides a key focus on the understanding of business needs and practices within the professional measurement and mapping industry for LaserTech. He has provided field-to-office product solutions for various industries for more than 20 years. We'll also be hearing from Mike George of DDSI Global. Mike is a GIS Director, a licensed UAV pilot and project manager at DDSI Global. DDSI provides survey drafting and geomatic services to oil and gas, telecom, and local government sectors. And we'll also be hearing from Steve Colburn, Applications Training Specialist at LaserTech. Steve has been a true pioneer in product development, marketing, sales, service, and support at LaserTech and has been doing so for more than 25 years. He has a Bachelor's of Science in Geophysics and has previously worked in the oil and gas industry where he learned the surveying trade. Now at this time, I'll turn the presentation over to Derrick Reish, who will kick off the presentation. Over to you, Derrick.
Well, thank you very much, Grace, and GPS World. Really appreciate being here today. I also appreciate everybody here live listening to this content of the webinar. And if you're watching the recording, thank you very much for watching the recording. So we'll go ahead and get started. We're covering what the just a little bit more about the webinar summary. So we're going to talk today a little more about combining laser rangefinders with products you already have, GNSS receivers, smart devices, and different apps. All about that field data collection workflows. Steve's going to go over a few other things about different mapping workflows, utilizing the laser rangefinders in with all these different devices, and talking about these. You know, we all run into challenges when you're in the field trying to collect the data. And so we're going to talk about that and talk about different ways to overcome those barriers. And Mike George is going to go through different scenarios on case studies. Laser Tech, we've been in business for over 34 years. We're based here in a suburb of Denver, Colorado. So we design, manufacture, and distribute laser rangefinders that measures distances and angles and different values. Here in our office, we do have the service and support team. We also have different service centers across the world. Speaking of that, we have a lot of our distribution channels across the world. So if you want to see a demo or learn more about our products, definitely go to our website and take a look there and find a local dealer in your area, and they can go out there and definitely show you a little bit more about our lasers and all these different workflows we're going to talk about today. So I'm going to give it over to Mike, and he'll give you a little bit more information about DDSI.
That's great. Thanks, Derrick. So yeah, I just wanted to give a quick thank you to DDSI and to GPS World Magazine for helping us out today. And I just wanted to once again give a quick summary of our company. DDSI is a design, drafting, and survey company with over 20 years of experience. We're headquartered in Tulsa, Oklahoma, and we have field offices here in Denver, Carlsbad, New Mexico, Midland, Texas, and also in Detroit, Michigan. Our groups oversee field crews collecting survey-accurate data on a daily basis. And as was previously mentioned, we work in the oil and gas industries, telecom, and commercial and residential, as well as local government, where we provide survey services to pretty much all phases of construction and planning.
Perfect. Thanks, Mike. Really appreciate your expertise here today and just talking about all the tools that you use. We're going to go into a little bit about what lasers are, laser rangefinders. So the Laser Tech, here we focus on pulse technology, which is AKA reflectorless technology. So we can get a range to almost any object without a need for a reflector. So as long as you have a clear line of sight, we can get a measurement to that object. So that's our laser sensor built in all of our laser rangefinders. Then we also have a tilt sensor built in. This tilt sensor is measuring vertical angles. You can see here just on the right hand side doing the plus or minus 90 degrees. So that's used for height measurements, clearances, and elevations, and etc. that you can use a combination with the laser sensor. And then in some of our lasers, we have a compass sensor. This compass sensor measures azimuth or direction or bearing, gives you those values. What's unique about the compass sensor here, there's no pitch or roll limitations. So you can be at 45 degrees or negative 45 degrees, and the azimuth accuracy is still going to be the same. And we'll go over those specifications here shortly. So what does that look like? What it's looking like here is what we've got is our laser sensor, SD, indicated down in the bottom diagram there, slope distance or line of sight distance. The tilt sensor, we represent it as INC throughout some of our diagrams, and that's the degree of inclination. And the compass, it does AZ, or the diagram on the right, and degree of azimuth. So we've got our 2D lasers and like 3D lasers when we incorporate that compass. With the press of the fire button, all our sensors measure, depending on the model. And once we get those measurements, the unit automatically calculates that VD, or vertical distance value, and HD, horizontal distance value. Automatically does that. You get to see all those values in the display of the True Pulse laser rangefinders. Now those values will output through a serial port and Bluetooth. We have units that do have wireless communication. Not only measuring distances, but and angles, we have onboard routines, making it a professional laser rangefinder. So one of that routines, what the tilt sensor I talked about earlier, is you're able to measure height or clearance. So we've got a 3-point height routine in the diagram up to the top left. And so taking some measurements, take those 3 measurements, it automatically calculates that height, and you'll get an output with those measurements, and you can see that height value. We also have what we call missing line routine. So on the right diagram, measuring 2D slope. We can measure the slope percent. We can measure that length of that slope just by 2 shots. And so what that is what we call a missing line routine. And when the compass is incorporated in the lasers, now we can do like a 3D missing line routine. So if you want spans or widths or anything of that nature, you take 2 shots. Again, this is all taking measurements from a good, safe location, away from the objects, away from roadways, and take these measurements, and you're able to take a couple shots there and get those values, which is really good to take a look at and download into different apps. So the models we have, that we'll be talking about today and integrating into different workflows, is the first one is our 2D, the TruePulse 200 series. We've got our TruePulse 200 and our 200X. And you can see the different range accuracies in the specifications. The TruePulse 200 is 8 inches, and the TruePulse 200X we're down to 1.5 inches. So again, that's our range accuracy. You can see the range that we get out to. That specification is out to non-reflective targets, like I talked about, reflectorless. If you actually use a prism, you can reach out farther to those targets. So we're just showing what's regular targets, non-reflective targets that you get out to along that range, and you can see the different waterproof ratings. One thing I forgot to put in here is about the Bluetooth specifications. The TruePulse 200 model has Bluetooth integrated. It integrates with Android, Windows, and Windows Mobile. The TruePulse 200X is our only laser that actually integrates with iOS, along with all the other different operating systems. Once we put the compass inside the unit, now we call that the TruePulse 360 model. The difference between these two models here, we've got our TruePulse 360R and the TruePulse 360. Is the 360R is built in a ruggedized waterproof housing and is in a horizontal configuration, kind of a binocular style. So it's 2 different styles that you can look at. Then also the specifications are the same that you see here. One thing to note is the azimuth accuracy. That's our biggest thing I talked about, is we have no tilt or roll limitations with this. And so we're down to 1/2 degree. So that's really going to come into play when Steve talks about some position accuracies of what we're looking at. So and when I'm going to turn it over to Steve, he's going to talk more about ways you incorporate laser rangefinders and different data collection workflows.
All right, thanks, Derrick, and welcome everybody to today's webinar. I'm going to go over a couple of workflows here that you all are probably very familiar with. This first one is kind of a GPS alone type workflow for your GIS data collection. Typically, you've got to walk up to the feature. You've got to occupy the feature with that antenna, right? So you've got to get up close to it. You've got to maybe position it just right, get it on, maybe a south side of an obstruction or something like that to get a better view of the satellites. You've got to wait for your signal. You make sure you get in your proper accuracy for your points and stuff like that. Put all your notes in, verify everything's good, take the point, and then walk on to the next feature and repeat all that, right? So that's kind of your typical workflow for GPS alone. And then another source technology that's being used for data collection these days are drones. And they offer great advantages, collecting a lot of data in a short amount of time. And those of you familiar with this, kind of see this workflow. You've got to do your pre-flight inspection, make sure you're not flying over any private property or anything like that. You've got to put in your ground control points, get them put into, pretty high accuracy level, make sure they're visible and everything. And then you go to wait for, good weather to launch and do your flight plan. And then, of course, bring it back down to Earth safely. But you really don't have a whole lot of QC there when you're in the field. You can't really go look at the data in any great detail. So you just kind of got to hope you have everything you need. So, Mike, your outfit has certainly done these kind of standalone workflows in your normal course of business, right?
Yeah, that's correct, Steve. You know, one of the main challenges for us in surveying is that, you know, rarely do we know what the field conditions are going to be for the project that we're completing for the day until we arrive on site. So it's very important for us to have the right tool for the job and to be familiar with its shortcomings, strengths and shortcomings. So in this picture that we kind of show in here, it's you know, kind of highlighting that we're trying to utilize the best tool for the job for what we're trying to accomplish. So, you know, in a lot of cases, physically occupying the point is the quickest and most efficient way to capture something, you know, or an asset, for instance, on the far left, where we're capturing a property pin, a location for a property corner, or in the center where we're using
you've got safe, easy access to that, right, Mike? And you might have to read a tag number off that pin or something anyway. Yeah.
Exactly. Yep. We have to capture that. We have to record what the text is on that. And then over on the far right, where we're preparing for a drone flight for one of the oil and gas assets that we monitor, you can see there's a communication tower on the far right. We're using a total station particularly to get the height of that pole is not necessarily the best tool for that. And we're trying to stay outside the fence, so we're able to do that safely and accurately by using that laser for that task.
Yeah.
So we try to utilize all the latest and greatest software, and you know, for data capture and creating digital twins and measuring precise measuring of all of these existing features.
Yeah, well, I love your concept of the toolbox. You know, you really got to try to outfit that with as many different technologies as you can, or at least that are going to be useful for the job for the day, right?
Yep, that's absolutely correct.
You talked about some of the challenges you can run into then with some of these standalone type measurements. Say you've got to get a point that isn't in a safe location with the GPS, right? It's out in the middle of the street, a manhole cover or something like that. Mm-hmm. You don't want to have to shut the road down or anything to be able to get that data safely. Or you have to position something underneath tree canopy. You know, it's maybe not visible from that drone picture, that drone flight that you flew. You've got something that's blocked, visibly blocked by it. Or just kind of access things. It's across the river on private property, something like that, where it's just going to take too much time and be inefficient to actually occupy the point. And then sometimes, even if they are easy to occupy, if you've got, 100 points in an area, why take the time to walk around and occupy each of them if you don't have to? And then we have this last example of trench, which I'm sure you guys have run into, where sometimes it's just not safe to get down in the trench or something like that.
Yep, Steve, each one of those is something that we come across almost every day. Yep.
Right, so here's an example you guys ran into, right?
Yep, that's right. So this is a perfect example of what you were just describing. So this is this was a parks project that we were working on, and essentially the scope of work was for us to capture all the existing features, including the underground, buried irrigation system. So of course, once we got on site there, quite a few of these valves and sprinkler heads were within the obstructed areas. And in this specific scenario here, you can see that the irrigation head was heavily obstructed, and we were it was physically impossible for us to put the pole in the GPS receiver and get a clear signal. But just 10 yards away, just stepping out in that area, we were able to get, essentially occupy the control points that we needed to do the offset routine, and not have to stop and switch gears to potentially use one of our other pieces of equipment like the total station just to acquire this single point.
Right. Perfect. So sometimes there's environmental conditions that kind of can slow you down out in the field too. We kind of mentioned the visual obstructions of foliage and stuff like that, but sometimes you got to shoot through a fence or whatever. And a few of these even come into play with our laser products. As Derrick mentioned earlier, it's line of sight. So you can't have any obstructions, and we've got some ways to get around some of that with onboard options, but sometimes that can be a factor. You've got to move to where you have clear line of sight of your target. And then weather can get you down too, right? With just about any technology, if there's just too much moisture, snowfall in the air, then you're going to have trouble. And then we talked about dangerous areas as well. So, and sometimes you think something's going to be visible when you get out to the field, right? But then some kind of temporary situation has occurred, and you got to be prepared for it, as you said, right, Mike?
Yep, that's right. So even in this situation where you're looking at here, where this is for one of our telecom projects, where we need to capture all the existing features, including the underground utilities that are marked by our partnering third-party locating service. And even though we're not in technically a busy street, right, where we might be able to physically occupy this point, you know, a critical asset to the project is located underneath the parked car. So this was a perfect example while we were, you know, essentially collecting all the utilities. We're able to take use the offset routine and capture that manhole without essentially, you know, having a neighbor come out, which we have had quite a few times. You know, after they ask us what exactly we're working on, they, you know, typically they're willing to help out and say, hey, would you like to? Do you need us to move the car? And we're like, no, we're all good. We can get it from just using this laser we've got attached to our pole and capture the feature and move on to the next one.
Right. So let's talk about this concept of a laser offset that we've been alluding to. Essentially, you know where you are with your GNSS, right? You put that pole down on the ground, you run your software, you get your, you know, certainty position and everything. You know you're in a good spot there. And then to capture that remote location, you essentially just point and shoot it with the laser. And it's going to measure distance at least. And then, as Derrick mentioned, some of our models have compass on it as well. So that's how you establish then that remote coordinate for the point you're after. You know where you are, you apply either distance azimuth or a couple of distances, and you can generate a coordinate for that remote position. So that's what we're talking about when we mention a laser offset. So let's go through some of the workflows then, the different workflows that you can use with GNSS and the laser. The first and really the easiest is a distance azimuth using those 360 models that Derrick mentioned. There you stand on your known point. We show a guy on a street corner here, and he's got his GPS. He's going to grab a position there, and then he's just going to point and shoot to that manhole out in the street. One shot. He measures distance and azimuth. And from his known location, if he's got declination applied properly to the compass bearing and stuff, that'll generate a good georeference coordinate for that remote target. So, you know, super quick method here. You can imagine if he had, you know, 10 or 15 objects to shoot around there, he could just pop them off really quick and put all those points into the data set. So another one that you can use with the compass, it's not used a whole lot, but it's especially helpful if you can't get a distance to the object. Maybe it's obscured by something or too weak a target, too far away. You can measure 2 azimuths. This will require 2 known positions, as you can see in the diagram 1 and 2 here. And you just use the 360 model compass azimuth to measure to the object from point 1 and measure the object from point 2, and then the software can generate that solution over there. So you guys have used this distance azimuth method in the field, right?
Yeah, that's correct, Steve. Yep. You know, we try to implement, you know, once again, whatever of the different routines you just went over to that, you know, fits the situation that we're in. And so for this one, this is another telecom project that we're working on where we need to collect the utility building attachments So depending on essentially their location, our previous solution was just to place the survey pole directly against the building and essentially hope for the best. That typically would cause some GNSS multipath errors and thus mislocating the features, and we wouldn't most of the times wouldn't figure it out until we got back to the office. Our other previous solution.
When you get them clustered close to one another like that, it just exacerbates the problem, right?
It does, and you know, we would end up having to try to our other way around that was to create a physical field sketch in our field books that would then require us to actually using tape measures to pull off of building corners, and then we would need to give that and pass that to our team of drafters for them to interpret and then add to our deliverable. And now we're just implementing the LTI offset routine to complete the task in essentially a fraction of the time.
Right. I mean, you get those in a matter of minutes, and you're out of there. Yeah.
Exactly. Yep.
Right. So a couple of the other workflows that are available using the laser offset method. One here is distance, range, distance, whatever you want to call it. You're essentially measuring distance to the object from two known locations, kind of like we did for the azimuth routine. So you occupy your first point, you take your distance measurement to the feature, back to the manhole in this scenario. Now you're going to be measuring distance and tilt, as Derrick mentioned earlier, so you'll get good horizontal distance for your XY or lat long location of the object, and then you'll get a good vertical distance so you can track elevation of the objects as well, or your height value. So that's really important. So you would take those two shots, and if you can imagine, there's going to be two solutions for it, right? One on this side and one on the other side. And most of the apps will just allow you to pick the side you're on, and you just do that, that shot out in the middle of the street, and away you go. So a great mapping method. You're not utilizing a compass. Maybe in this urban environment here, a compass may not be reliable. It might get too much deflection from local sources. So going with a range solution like this really eliminates any worries there.
And it's highly accurate.
Yeah. Oh, yeah. Yep. I'll cover that in a minute here. Another one that can be effective where the compass isn't is this distance angle. Another product we have is called our True Angle device, which will just measure a horizontal angle with an encoder. Isn't affected by any local attractions or anything. So in this scenario, again, we're back on the side of the curve. We're going to take a reference shot with the encoder just to kind of get us onto the grid we're working with. And then we just turn our angle, and then that's just a single shot, like the distance azimuth routine, to the object. And that within the software does create a distance and azimuth to use to calculate that remote coordinate. So another great way to get data in environments like this, and another super accurate way too. That angle encoder we have is really accurate, more accurate than the compass reading, so you can really keep your data tight. So another example of you guys using this range intersect here, huh, Mike?
Yeah, so this is actually going to be one of the case studies that we're going to touch on here in just a few minutes. But yeah, that's correct. So this is an area where we have some utilities that we needed to locate for another one of our telecom projects, and you can see that essentially the information that we're trying to obtain is obscured by the vegetation. So what we have here is exactly where we thought that where we're going to be able to occupy the 2 points. And, the first step of this routine is now essentially included out of the box of most of the apps that Derrick's going to also touch on here a little bit later. And it allows us to quickly acquire the required control points and then accurately capture the offset for each one of these different assets, which we're going to have there's some communication lines down there, there's some power lines, there's some gas lines, so all that needs to be added into our deliverable. And it's,
right.
From the picture here, you can notice that we're safely on the sidewalk where we've got a clear view of the sky once again, and, we're away from the street. So it works out great.
Right, but again, you can't really trust in an urban environment like this, you can't really trust that compass is going to be 100% reliable. There may be something buried just on the sidewalk there that might screw you up. So range is just a real safe, accurate way to go, isn't it?
It's perfect for this one because the utilities are densely essentially laid together down here in this area. So, having that extra accuracy was the difference for, this particular set of utilities.
Yeah. So let's talk about some of the accuracies for these methods that we've been discussing. You can see at the top of this table here, the table is separated by a mapping method, product, and then some accuracies at a couple of different distances that you might run into. You can see at the top here these range values. We're nice and tight with even the standard true pulse models, but then great within a couple inches with that 200x model. And you can see one important thing to note is that it doesn't change when you go from measuring 150 feet to 300 feet. It's all based on distance, and those distance accuracy of our lasers don't change over that range. So your position accuracy will remain the same as well. And then with the range azimuth and the range angle methods at the bottom, because you're measuring that horizontal angle to the target, and there may be some error in it, that error will increase over distance if you follow that. So at 150, say, range azimuth with the 360, we can be within 10 inches or so. When we shoot twice as far, we essentially have the possibility of twice as much error. So that's how that goes, and you can see all the different accuracies here. So a real handy chart. You've typically, Mike, you've got an error budget for a project, right? You've got to position those points, say, sub-meter, right? So you can go to this chart and you can say, well, if I'm using a 1-foot GPS, then I've got to use this particular laser offset method to make sure I stay within my error budget. So that's kind of how a lot of folks are going about it. Don't forget about your GNSS error and the necessity to add that into your final position error for your points. So that's all I had to discuss right now for the flows and accuracies. Derrick's going to give us a look at some of the different apps to use.
Hey, thanks, guys, walking us through all those workflows. So we're going to give a little overview of a lot of different apps. What app might be best for you? You might already have some of these apps or software solutions and did not know there was a laser interface built in. So I'm just going to give you a kind of a snapshot of each one of these through a couple of them. And one thing I'll probably mention a couple times is we have a lot of technical documents on our website that do a step-by-step instruction of interfacing with the app, setting up the laser, going through each different workflow Steve and Mike talked about. And so we're going to go through each one of these. The first one we do actually we develop apps ourselves to integrate with our lasers, and one is called LaserSoft MapSmart. We started this a while back, started just more for laser mapping. So you'd set up a origin at 000, and then you use the laser, different lasers, different mapping methods, and capture points, lines, polygons, etc. It was just a really quick, easy way of capturing our laser data that I talked about earlier, all those different measurements. Then we started integrating GPS into this app. So then you can use the internal device, GPS, or external receiver, and so you can do GPS only. But as you can see, kind of what Steve and Mike were talking about, all those different combinations and stuff, one of them, to maximize efficiency, was adding a laser and GPS together to do that laser offset. You can walk around, quickly stand, grab that position, and take some offset points. Another app, just giving you a quick snapshot here, we've been working with Leica on some other apps before. Their latest version of the Xeno mobile app, they've incorporated the laser rangefinder. They released that back in 2020, and it's all on Android. So it's real simple and easy to use. And Steve mentioned a couple different mapping methods, and each one of these apps have a different terminology for those workflows. So like horizontal distance and azimuth, distance, and then they have the azimuth that Steve talked about. And you can see the requirements for each one of these that go into working on this the Xeno mobile app. So you can see everything is right there, the display on the map on your smart device. You're able to see everything happening right there. Again, we have those technical documents that do a workflow, step-by-step instructions for each one of those workflow mapping methods. We've been a Trimble business partner for many years. We've had a laser interface built in different apps and different softwares from Windows to Windows Mobile. The TerraFlex app does have a laser interface built in. This workflow is more adapts to you. One thing, what it does is it takes the accuracy of the laser, the accuracy of the GNSS or the receiver, and it applies it to that position accuracy that Steve talked about. And if it doesn't fit into your tolerance, it will automatically go into a different routine. So if you started off with that single shot routine or single shot offset, and your tolerance wasn't what you needed, it will automatically take you into that two-shot offset. So it's a really wizard-like workflow that walks you through things, so you can see everything happening right on the map, right there on the screen. So, and then also the different requirements. Again, I want to talk about they have TerraFlex goes on all different operating systems, and our 200X is again the one that works with the iOS devices. The Esri ARC field maps, also note the previous collector. We do have a workflow into this app. It's a well-known one, or very popular in the industry. The way we do this is we've partnered up with EOS positioning systems, and this is how you work with to get the lasers to integrate with those two different apps. So we do have a workflow that's in the collector or field maps. And inside that, it will call up the EOS Tools Pro app, and it goes through these different workflows. This is all on iOS, so if you were using a TruePulse 360 for some of these workflows, it's a manual entry into the Tools Pro app. And then once you capture the distances and everything, it goes right back into the app, or back into collector or field maps. I mentioned we work with a lot of different companies, a lot of different apps. I'm just not going to go through each one of these, but you might notice some. You might see some that you recognize. You might have this now on your smart device or Windows Mobile even. So we would still work with a lot of people that have Windows Mobile devices. So Steve and the team, we put together all these technical documents, again, instructions to walk you through these. So it's on our website. So if you recognize any of these and say, oh, yeah, I want to learn more about how a laser can be integrated there and the workflows, we have that instructions there. So we have worked with a lot of different apps. And not only that, like with all these different apps and how it's used, Mike's going to go into more of those user case studies of how it all comes together and what he's actually collecting out in the field. So I'm going to turn it back over to you, Mike.
Great, thanks, Derrick. Very informative to see how many different software applications you guys are tying into. That that helps out a lot of people that are using a wide variety of different apps and software packages these days. So. Yeah, thanks. And I'm going to go ahead and dive into a couple of the case studies that we are going to highlight today, where we've implemented some of this technology and workflow into our real world projects. And we're essentially going to, how we're applying this high accuracy technology, and then some examples of how we're pulling it together with both GIS and CAD. So the first one that we're going to talk about is another telecom site where we're essentially doing a site modification, and how we're implementing the offset routine to save us some time in the field. And what we're looking at here is a lease area for an existing wireless monopole design. And the statement of the scope of work for this type of project is essentially we need to survey the existing monopole. We're tying down the parcel boundary. We need to as-built the compound that we can see down there, and we're capturing all the third-party utility locates that's going to come into play here in a second. And then the end goal is to produce a licensed surveyor stamped exhibit, which essentially turns into a legally binding document that essentially is used for additional access and utility easements to potentially increase the number of wireless providers and further add bandwidth for this location. So what we're looking at here is some of the utility locates, and it's a close-up of the lease area from some of our high-resolution drone imagery. And contained within this site is a variety of equipment that all needs to be captured by our field crews, including any existing concrete pads and structures, the H-frames that hold the wireless provider's specific equipment, of course the tower itself, any handholds, that's where the fiber cable splices can be accessed. And then for our demonstration, the underground utilities located by our partnering private locator that are marked in red for electric, orange for the communications or fiber, the comms, blue for water, yellow for gas, and green for sewer. And then we typically have our drafters add these in locates right from the imagery, especially of a clear view from the sky, but what if you can't see your assets? And this is another picture of that, what we briefly talked about a little bit earlier, where you can kind of see here where we ran into this project where we've got a group of tightly spaced utilities that were obstructed by dense vegetation. And you can see here in the yellow boxes that we've got a group of electrical and communication pedestals. They're all clustered together, but only two could be seen from the imagery. And from the ground level photo, you can see there's 5 or 6 that are actually there, all separated by different utilities running into each of them. So this is where we implemented in this scenario the offset routine, and it was a huge time saver for us here. When in this case, as we showed the overhead picture from before, we utilized the range offset routine, which is the most accurate of the routines that are available. And one field member essentially now can capture the visibly obstructed assets quickly and most importantly accurately without having to stop what we were doing, switch gears to potentially a different set of equipment. Then we can go ahead and move to another location where we have a clear view of the sky, obtain the 2 accurate GNSS control points and produce the required laser offset, and then move on to the next point. So here are just a couple of screenshots of this that I wanted to show essentially how easy it is. And in this example, we're showing field maps from ArcGIS. And this first step of the routine is now essentially included out of the box, and it allows us to quickly acquire the required control points and then accurately capture the offset location of this asset. And once again, notice how we're safely we're out of the vegetation cover, we're in a clear view of sky, and obviously away from the street. So one of the pluses obviously is that we can quickly acquire these points, and we did not need to use any backside or checkpoints just to acquire these points that we needed for these different utilities. So in this screenshot, what I want to show is some of those building attachments from that previous slide that we talked about earlier in the presentation. And in this example, this is where we're using the EOS Tools app and ArcGIS field maps. And the range intersection selection screen provides immediate feedback showing the offset point in the correct location. So when you can see that up in the upper left-hand corner, you can see the 2 circles where you've got where we've taken our 2 control points, and then there's the offset. And in the bottom left-hand corner, you can see the accurate feedback that we get right away. So this allows the field crew member to quickly QC the data and know if the building attachment is the right location, and then submit and save securely to ArcGIS Online. You can just see right there where the circles line up exactly in the base maps, which I can't stress enough, like how helpful that is to us in the field. It's a huge time saver. We know that we've captured the point correctly, and we can just move on to the next feature. So while we're initially capturing this offset point, there was once again some partial vegetation to the second control point. And in the range intersection screen, we could tell right away where the circles didn't line up, and it actually kind of showed us off over in that RV parking lot. And we could immediately tell that the laser received some interference from some bushes and that we needed to capture it again. So when we recapture the offset to get the correct location, so with these combinations of both the base maps and the accurate feedback provided by the EOS Tools Pro app, we didn't have to wait to get back to the office to figure out that the data point was inaccurate and we needed to throw it out and be collected again. So in this example, I'm going to show a couple of points that we briefly talked about for the City Park Survey. Here's an overview of the entire project where we're overlaying some of our drone data, and I'm highlighting a couple of the areas where we had some interference. So the scope of work included capturing all the existing features, spot elevations at a 25-foot grid, and at each sidewalk entrance. We're also required to collecting privately located utilities once again, the irrigation sprinkler heads and valve control boxes, and this is about a 5-acre site. The purpose of the project was to turn over data to an architecture firm to design new ADA compliant ramps and overall park improvements. So it turned out that this once again was the laser offset routine became a perfect tool for the job, and then these vegetated areas here were one of the obstructions that we had to deal with. And so in the northeast corner of the park, you can see we had about the same dense canopy obscuring the clear view of sky by these large pine trees. So there's a sprinkler head right there in the center there that we needed to capture. So we could have tried to stand in that spot, possibly, maybe average 30 to 40 points, and ideally hope for the best. But why chance it? By using the range routine, we could step out into the clearing, allowing us to gain a fixed DRS position, GNSS position to get sub-inch control point accuracy to then perform the laser offset routine. And a single field crew member was able to solve the problem without having to stop once again, reassess, and potentially ask for help to acquire the single point feature. This next example is another one of our telecom jobs, where this pole is slated identified for a wireless replacement. Each one of these poles here needs to have new power and new fiber pulled to each one of them underground, which means bored from an existing power or fiber location. So this is another scenario where we are required to capture all the existing utilities in that location. So by taking advantage of the laser offset routine, right here in the red you can show where there's a power line that is running from that pole underground over. So instead of crossing the street or occupying the center of it, by taking advantage of the laser offset routine, we were able to capture this point by either by it being obstructed, and it was difficult to access. Were no longer an issue. And in this case, we were able to end our polyline feature capture by shooting the end of the underground electrical wire marked by our partnering third-party utility locator. So in this next example is another deliverable that we need for some of our telecom jobs where we need to capture the height of the existing pole. So additional measurements are sometimes required for these telecom deliverables, and by taking advantage of the missing line routine built into LTI's 200X, we can now complete this with the survey pole attachment of the laser rangefinder. Then this information can be added to the attribute data within Field Maps or ArcGIS or any of the other apps that Derrick previously mentioned just a few minutes ago. So you can see here what we did is we used the missing line routine where we're using 2 angled shots where we needed to capture both the height of the pole and the height of the light attached. So those were 2 separate measurements that we needed to add in and add to our final deliverable. So we were typically using, sometimes our total station or other equipment, and now we're just using this piece of equipment, just the 200X to solve this problem. And in this next example, where we need to capture the example of height data capture required by, once again, by some of our other telecom clients. In this example, we took advantage of the height routine built into LTI's 200X. And most times this can now be safely completed. We could complete this safely from the ground. And then this, once again, we just add this information directly into the app that we're collecting the data with, or we'll add it to our field notes. But either way, we're able to capture this height, which is essentially, it's required by the FAA, and we need to document the highest point for all the telecom sites that we're on, that we're expected to deliver.
This is a great point here, Mike, that the laser can kind of run double duty, right? It can not only help you position objects, but then if you've got to record a height or a width or a slope measurement for that object as an attribute, you can use a laser to make a nice accurate measurement also and feed that information in.
Yep, that's correct. So we're using it on both ways. So not only are we using it for offsets, but we're using it to capture heights of essentially required features that the client needs to then turn that over to the local municipality to essentially approve their project. So yeah, we're using it both connected and disconnected from the pole. And then in our last example here, I just wanted to show, a screenshot of a final deliverable. This is of that parks project that I just showed a few minutes ago, where we have to provide our professional land surveyor stamp and signature. And you can kind of tell in the level of detail it was necessary to be signed off by our client. And so we're tying together where we need to capture every existing topo feature. We need to create a surface of the 5-acre parcel. So that includes, a surface model and a contour. And that's derived not only from our drone data, but our traditional surveying methods that we're collecting that. And that also includes engineering grade elevations, the irrigation heads captured, captured using the laser offsets. And then we're essentially, by being able to use all the different tools in our toolbox and utilizing our routinely implemented, offset routine, a laser offset routine, we're able to deliver this project on time and under budget. So with that, I think I'm going to go ahead and turn this back over to Derrick.
Great, thanks, Mike. Yeah, that's just great. All the different workflows that we talked about, and so just kind of summary of everything that Steve and Mike, myself talked about is just the bigger thing is measure more, don't have to move around as much, and the big thing also is being safe, not standing in the middle of the roads. Some of those challenges you might have. Stand on the side of the road and shoot to the manholes that way. It's a lot easier from the side of the road. So and you can see the different position accuracies depending on your tolerances of lasers and the different receivers. So you can still maintain that. So what fits your tolerance for the job? So you can see different all that. And just overcoming those field challenges. You're out there in the field doing this. I'm sure you run into a lot of those that Mike talked about and Steve did. And so also the biggest thing, also another big thing is just you already have these devices, but maybe did not know there was a laser interface built in. And that's kind of what we want to show, and show different ways of capturing, making the job easier in the field, quicker, safer, and faster. So we do appreciate the time today. That is all I have presenting, or we do. So at this time, I'm going to turn it back over to Grace and see if we have any questions.
All right. Thank you, guys. This was all really interesting and helpful information. I think our audience is really going to learn a lot from it. At this point, I am going to take us into our Q&A session. We're going to jump into some questions we received, some during the registration process from our audience, and a couple we got in during the presentation. And it's not too late. If anyone has any questions they're just thinking of, go ahead and submit those to us now as well. All right. So first question, would GIS applications really be a good solution to most construction projects?
Maybe you could speak to that one, Mike.
It totally depends. You know, I guess from the person asking the question, it depends on what type of construction project. There's certain assets that don't require an engineering level of accuracy. So, for instance, you know, the utility locates that we highlighted today. You know, those are typically those could be anywhere plus or minus a foot, right, from where the utility locator captures that under the ground. So when they mark that, you know, they're essentially 6 inches on either side of that marking of where the actual asset sits. So if you're at, you know, essentially sub-centimeter accuracy with your GNSS device, and then your offset, you're well within the threshold of the actual asset being located on the ground. So, you know, it really depends. Obviously, a GIS is not, or I guess that type of data capture is not suitable for all forms of construction, but it completely depends on what the deliverable is meant to be.
Okay, thank you. All right, and do you have to calibrate compass in the TruePulse 360 models for azimuth accuracy?
Yeah, I can take that question. We do have user field calibration routines on our units, especially with the compass. Steve did talk about that magnetic interference at times that could affect the compass accuracy. And so we do recommend when you get to a site, it's about a 30-second routine to calibrate the compass. We want to make sure you maintain that azimuth accuracy. And we have indicators in the display. When you're looking through the display, you're seeing these indicators that tell you, hey, it's time to calibrate the compass. Now, if you move around that site, it's okay. Now, but if you jump into your vehicle and drive to a whole new site 20 miles away, we suggest doing the compass cal once you get to a new site.
Okay, thank you. And this is a question submitted during our event. Do you have visible laser beams in your laser devices?
That's a good question. That's something I didn't cover. Our lasers are Class 1 eye-safe, and the ones we're showing today do not have a visible beam. That's our pulse technology. So when you're looking through our display, you're looking right through our transmit lens, we call it. So you're targeting what you're seeing in the display is what you're targeting. So you can hit really small objects. So you're looking right at it. Our beam size is really tight, so we can capture those little tiny targets out there, and you're looking right through there. But there's no laser beam coming out of the unit. But the way we've configured our lasers, you're looking right through where the laser does go, and so that's an easy targeting that you can acquire the measurement. Sorry.
Awesome. Okay. And then also, are the lasers Bluetooth compatible to any smart device?
Yeah, that's another good question. We do have it depends on the model. Our TruePulse 360 models, they can talk to Android devices and Windows devices or communicate. And then our TruePulse 200X is our only one that talks to iOS devices, but also with Android and Windows. So it just all depends on the model. But we are able to talk to smart devices that way.
Okay, cool. And do you have a solution for reverse tasks, such as finding the point on the ground, having the coordinate on the map?
Yeah, that sounds that kind of sounds like a stakeout function to me, where you've got to put a mark on the ground and you have a coordinate for it. And our systems could be used for that. It would just depend on the app and if they had that function to upload a series of coordinates and put them out that way. So that's possible, yeah. Okay.
And will there be LTI LRF support for ArcGIS Survey 123?
Yeah, integration directly with the Survey 123, the Esri app. I've been working with the development team on that, and so we have some things in the works. A lot of things are going on with the App Studio, and so we hope to see some new things coming out here very soon with integration into App Studio that can be taken into Survey 123. So we are continuing to work with that and hope to have something here in the near future with an integration.
Okay. And how safe is the laser technology?
The laser technology is very safe. That's Class 1 eye safety, so it's the power of that does not affect. It's eye safe. So they're very safe to animals, to humans, everything that nature. So it's again, Class 1 eye safe.
Okay. And this is a question we received towards the end of our presentation. In that FAA height requirement picture, how do you hit the tiny pole on the top of that steeple with a laser? That's a good question.
Yeah, people are often amazed how small a target we can hit with our stuff. It's a very low energy laser, as Derrick mentioned, but a really powerful one as far as measuring distance goes. And another consideration is you could hit that steeple on there probably pretty easily, but I believe in Mike's slide, he was using our 3-point height routine where you just measure the one distance. And then the shots to the base of the object and the top of the object, or the steeple in this case, are just vertical angles. So all you're doing is just pointing and measuring an inclination. You're not even getting a laser response in that scenario. So, yeah, that's a good question.
Okay, and then kind of related to this, when measuring heights, what type of height accuracy can you achieve?
Yeah, we've got a table on our website that will go over that for the different models. But the TruePulse 200 and 360 models, you can typically measure within a half a foot height. And again, this is dependent on how far away you are from the object. As I mentioned in the position accuracy earlier with the horizontal angle, when you're talking about heights, the inclination you're using here, that error will increase over distance. So typically in most common working distances, we like to call it, you can stay within a half a foot with those models, and then the 200X will keep you within a couple inches of height measurements.
Okay, great. And do you have a good workflow for capturing assets such as MH, valves, etc., on a busy street or highway since they need to be line of sight?
Yeah, kind of as we showed in those diagrams, you can really use any of the methods as long as you have that line of sight to it. And you'd be amazed at how far you can shoot down the roadway to objects that are kind of flush mounted to the surface. You can get down 100 feet in some cases down the road to the object and have that line of sight to it. So you're typically closer than that. So people get good response. We've had customers go out and test these range intersects on manholes in the middle of the streets, and they go back out there with their RTK GPS, and they're just right over our points. So it really works well.
All right. And I think now at this point, we're unfortunately out of time. I know we did receive a couple other good questions, so those questions will still go to our presenters. You may be able to hear back from some folks at LaserTech in the coming days. So at this point, we are going to wrap up today's event. I want to thank everyone for coming and for attending today's webinar, Collecting Remote Asset Locations Using GNSS GIS apps, and laser offset mapping, brought to you by GPS World Magazine and our sponsor of the event, LaserTech. Now, if you have any additional questions for myself or our speakers, you can reach out directly via the email addresses you see on the slides. And you should also note that today's presentation slides are available to you for download via the resources panel at the bottom right corner of your console. And a recording of this webinar will be emailed to you tomorrow. You can also access the on-demand version of this webinar anytime from gpsworldmagazine.com/webinars. Upcoming webinars from GPS World also will be posted to that page. Once again, thank you all for attending, and we hope you'll join us for another great webinar.